When we calculate limiting reactant problems, the question will have two givens in it. There'll be two numbers provided, and they will be reactants in the equation. So we will simply take each number and make separate calculations. When we look at the answers on how many grams or how many liters the product will be, we will pick the smaller answer to be correct, and we will say that the larger answer cannot even happen. And I will often say it's a lie, because I know you know that lies are not good. It's not going to be a good answer, okay? All right. And like I said, here's what I mean. Exactly. We'll take each given, and we will do separate calculations with them, okay? And they will both try to answer the question. So the answer will be the same unit. They'll just be different numbers we'll have to find out with calculating, okay? Now the easiest way for you to understand what I just said is really just to do it with me. So I'm going to do it on camera with you so that it will make the most sense. All right, and we just reviewed. We said the limiting reactant. Okay, the limiting reactant is the one that runs out. It's completely consumed. It makes you stop, so it limits the amount of product that you can produce. When the limiting reactant runs out, the reaction is finished. Just like having all these extra car tires, that does not mean you can keep making cars. You need the bodies to go with them. Or when molecules are left over, just because you have them, you cannot make more molecules because you're missing the other ingredient needed, the other reactant. Let's do example 10 that's in our notes. In the question, it says we have 3.2 moles of aluminum, and it will react with 3.2 moles, and that's hydrochloric acid, but I'll just say HCl because I know you can read that faster. The question is, how many grams of hydrogen? We want to know how many grams of hydrogen. So in this problem, the unknown is the hydrogen. For all the calculations, the unknown, when you look at the foldable and it tells you liters of unknown, grams of unknown, okay, the unknown is hydrogen because that's in the question. And the given, we have two of them. At first we'll have aluminum as the given, and on a separate calculation we will have HCl as a given, but they're going to be separate calculations. To make sure mine is readable for you, I'm going to do it on separate paper. 2 aluminum react with 6 HCl to make 2 aluminum chlorides, okay, and 3 hydrogens. Okay, we're going to do our first calculation with 3.2 moles of aluminum. And as you know, we always put the given over 1, don't we? Okay. So we're starting our calculation. And remember, we want to know how many grams of hydrogen. That's my question. All right, to do our work, it starts with moles. So should the foldable be opened or closed to start with moles? Closed. Good job. So this will be closed. All right, I'll clip it so it won't open up on me. All right, and it's asking me for grams of hydrogen. So at the end, should it be opened or closed to have grams as my answer? Open, I heard you, yes. Molar mass, when we get there, we'll use molar mass because that's how we'll get grams for our answer. Okay? All right, we keep that open. I want to paper clip it open so it cannot close on me. All right, there's our setup. We have 1, 2, 3 columns, and then we'll have an equal sign. But I'll draw the columns when I see how much room I need. Okay, let's begin. So moles of aluminum, do we want moles of aluminum in our answer? No. So do we copy it to top or bottom? Bottom. Okay, just like always, same steps for how to solve. Moles of aluminum will go on bottom. Okay? Now, and that's what the foldable says too, moles of given. Okay, what goes on top? Moles of unknown, right? Since moles is in the bottom for the first time, we know this is the mole ratio. And it says moles of unknown will go on top. Now remember, the unknown is what we're looking for. So H2 goes on top. Oh, and the foldable said we want moles of it because we're doing the mole ratio. Questions? So you see how to get the numbers and you see how to read the foldable to know what to write. Okay, draw a line because now I know how much room I want. Okay, after getting moles of hydrogen on top, do we want moles of hydrogen for our answer? No. So that means we have to copy it to top or bottom. Bottom, to make it cancel, okay, to make it go away, we have to copy it to the bottom. Moles of hydrogen. Okay, and that will make it cancel, won't it? Moles of hydrogen, canceled. All right, what are we looking for again? Grams of hydrogen or liters of hydrogen? Grams, right. The question said how many grams of hydrogen. So I'm putting grams of hydrogen at the top. And, oh, look at that. The unit we want grams of hydrogen. It's written at the top. So I know that I have enough columns. Not to mention the foldable tells us we have enough columns. And we will do the equal sign there once we have all the numbers in. Questions? Okay, so the foldable tells you how to do it. And now it's going to kind of tell us what numbers we want to look for. We have to know what the words mean, but we can look for the numbers. All right, here we have grams. So am I going to do molar mass or am I going to do 22.4? I'm going to do molar mass. Right. Now, before I taught you to find molar masses earlier, but we can do it now. Okay, hydrogen on the periodic table is 1.008. Okay, that's hydrogen on the periodic table, the atomic mass of it. But our formula says how many hydrogen make that substance? 2. 2. See, it says H2. So I have to multiply by 2 because the formula told me to. That's why back in the early 80s I learned to call it formula mass before I ever learned the term molar mass. Because you look at the formula and you find the mass of what it says. We call it, it's molar mass, the mass of 1 mole. All right, 1.008 equals 2.016. Does everybody see how I got that? Okay, so we got the molar mass now. Yay! All right, let's read the foldable. Okay, what do we write here? The foldable says 1. So that is why we put a 1 here. Okay? We do put a 1 there. Let's go to the next column, here and here. It's got moles over moles. If you look at the foldable, here's moles over moles. It's the mole ratio step. What numbers do I use for moles over moles? Coefficients, yeah. Look at H2. What is the coefficient on H2?
3.
It's a 3. Does everybody see how we know it's a 3?
Yep.
It's just the number in front of the formula. That's a coefficient. That's where this 3 came from. Okay, look at AL. What is the number on AL? 2. So I put a 2. Questions? Where I got the 3 and the 2? You see how to read the foldable to find the information you need. It really does tell you what to do if you know how to use it. All right, let's calculate. Again, I will simply point to the numbers while I put it into the calculator. Calculator says, the work says 3.2 times 3 times 2.016. Okay, then we'll divide by 2. You don't have to divide by 1 if you don't want. And here's another one. You don't really have to divide by 1, but you can if you want. And then we hit the equals. Calculator says, okay, 9.6768, whole bunch of junk. But remember, we really only need 2 digits. Our question has 2 digits at the front here. So I'm going to round it to just have 2 digits in my answer. 9 point, should I put a 6 or a 7?
7.
7, right. So this time when we round it, it's 9.7. And remember, the only unit that would not cancel is the grams of hydrogen. Now, in other questions, you'd be finished right now. But this is not really the final answer. It is not. So what we have to do is calculate the other way. Okay, now the other given, let's look at the question again. We have 3.2 moles of aluminum, and we have 3.2 moles of HCl. So now I'm going to do the work in a second calculation with 3.2 moles of HCl. And the work is going to be very similar, and I think you'll like it. 3.2 moles of HCl. Okay, that's my other given. Okay, HCl is what we're starting with this time. That's a given this time. So anytime the foldable says given, we know we're going to use the formula HCl there. And you know us, we always put the given, we always put the given over 1. That part's easy, isn't it? Okay, let's continue the work. Do you want moles of HCl in your answer? No. So we'll copy moles of HCl down here so that it can cancel. Okay? Moles of HCl here, moles of HCl here, it cancels. Good. All right, so we have moles of given at the bottom. What do we put on the top? Foldable says moles of unknown, right? Okay, moles. What was the unknown material?
Hydrogen.
Yeah, it was hydrogen. Because hydrogen's in the question, hydrogen's the unknown. And yes, it is the same as what we wrote down the other question. Moles of this given, though, with the moles of hydrogen on top. It matches. Isn't that nice? Okay, do you want moles of hydrogen in your answer? No. So we're going to copy it to the next column. Does it get copied to the bottom or to the top?
To the bottom.
To the bottom. So moles of HCl, I'm going to copy it to the bottom. Sorry, moles of H2, excuse me. Moles of H2, we want to cancel it. So it gets copied to the bottom. Okay, what goes on top? What goes on top, please?
Grams of hydrogen.
Okay, you said, tell me again.
Grams of hydrogen.
Grams of hydrogen, yes. We're putting grams of hydrogen on top. So, oh, we did that before, didn't we? We had grams of hydrogen on top before. You see what I mean by it being similar? Okay, question?
Where did this second part come from?
You mean this?
The whole thing, like, you know how you said that we were done, that we weren't done?
Okay, because the question, this is very important what you're asking. Because the question gave me 2 quantities, I have to calculate one answer for one of them. We did that. And now we're calculating the second one. When we're finished, we will compare the answers. Very important question you asked. Thank you. All right. Any other questions how I got this information so far? You're okay with following your foldable and you know where the units come from. Okay, now that the units are written down, now we can put the numbers in and do the calculation. So it says grams of hydrogen. Oh, just like the other one. Well, we're going to use the same number as the other one. What was the molar mass of hydrogen before? It was 2.016, wasn't it? We're using 2.016 again. See how it saves a little time? What number goes on the bottom? A 1, just like we did the last time. Okay, now we can go back a step. We've got moles over moles. Where will the numbers come from? Where do I look to get those numbers? Coefficients again. Oh, H2, we had it before. What was the coefficient on H2 the last time?
3.
3, and it's still a 3 for this question also. 3. But here we have HCl. Okay, look at the equation again, hunt for HCl. What's the number?
6.
Right, the coefficient is a 6. Remember, coefficients are in front of the formula. So that's why this is a 6. I know you can reduce. I never bother, unless it's only a mole ratio question. So I can just calculate right now, can't we? All right, let's do that. I'm going to raise this up so you can see my calculator. And again, I will put the numbers in as I point. 3.2 times 3 times 2.016 divided by 6, and these are just ones, so, okay, equals, and we only need 2 digits, so the answer here will be 3.2. It really is what the calculator tells me to do. 3.2, and then remember, it's grams of H2, isn't it? 3.2 grams of hydrogen. Okay, now we have the 2 answers, but only one of them is true. Is it the bigger answer, or is it the smaller answer that's true?
The smaller answer.
The smaller answer is correct, okay? The smaller answer is correct, and don't scribble, but just put a very neat X or a slash on top of the big answer, because it is a lie. The big answer cannot happen. The other reactant is gone. It cannot keep reacting. What it's supposed to react with isn't there anymore. So the big answer cannot even happen. All right. On your paper and on the assignment and on the test, you will see questions that will ask you, what is the limiting reactant now? Now that you've done all this work, what's the limiting reactant? What's the excess reactant? You will be asked that. So here's an easy way to see it. Okay, see this bad answer? Go back to the beginning. Whose fault was it? Who are we blaming? Ah, the aluminum. Aluminum started it all. See it? The bad answer came from aluminum. Well, because aluminum made the big answer, aluminum is the excess reactant. Aluminum is the excess reactant. Now, I'm going to write it on the notes paper, what I just said. Okay? The excess reactant is aluminum. How did I know? Aluminum made the bigger, or you can put larger, answer. That's all. Aluminum made it happen, right? Aluminum is the reason that the bigger answer happened. 3.2 moles of aluminum is too much to go with the other. It made a bigger answer. Now let's look at the smaller answer. Okay, here's our smaller answer at 3.2 grams of H2. Okay, whose fault was it? Go back to the beginning. What reactant made it happen? Oh, the HCl, right? Do you see how you track back to the beginning and look who started it all? HCl started it all. So that means that our HCl, okay, HCl is the limiting reactant because it made the smaller answer. Good? HCl is the limiting reactant. Okay, I'm going to write that on the notebook, on the notes paper. HCl is the limiting reactant. How did I know? HCl made the smaller answer. Period. So that's how you know who made who the limiting reactant was.